What comes first when you think of inspiration for landscape and building design? Modern Tokyo or the movie Blade Runner? Quite a tricky one, right? Because interestingly, in the movie Blade Runner, Los Angeles is portrayed as a dark and overcrowded metropolis with tower skyscrapers, neon signs, and ubiquitous advertising. Doesn't this give you a clear imagery of modern Tokyo? With its population of over 35 million people, incredible skyliners with a height limit of 250 meters, and neon signs, Tokyo is a very beautiful city to experience jaw-dropping architecture, landmarks, and neon night lighting everywhere. But sadly, this city experiences earthquakes the most, like the Great Kanto earthquake of 1923, the 1964 Niigata earthquake, and the 2011 Tohoku earthquake, all claiming enormous lives and properties. Yet still, Tokyo adds another skyscraper, 330 meters tall, to its collection in Toranomon Azabudai district, the main tower. Tokyo's first super tall skyscraper with an insane engineering technique. So, what is the structure of the main tower like? What type of engineering technique does this super tall skyscraper use? Can it withstand an earthquake as great as the notable earthquakes Tokyo experienced in the past? Or, the skyscraper is a white elephant? Stick around to find all these out. And if you want to see more videos like these, hit the like button and also subscribe to our channel. The Earth's surface is made up of huge plates that float up on top of the hot magma deep inside the planet. These plates move very slowly, but sometimes they get stuck and pressure builds up between them. Now, when the pressure becomes too great, the plates suddenly move, causing earthquakes. Tokyo is located in a place called the Ring of Fire, where two big plates of Earth's crust meet. In addition to being located in the Ring of Fire, Tokyo also sits on top of a fault line, which is where two of these tectonic plates meet. This means that earthquakes are more likely to happen in Tokyo than in some other parts of the world. Another reason why Tokyo has a lot of earthquakes is that it's built on soft, sandy soil. This type of soil can make the shaking worse because it tends to amplify vibrations. This means that a small earthquake can feel much stronger in Tokyo than it would in other places. Finally, Tokyo is a very populated city with a lot of tall buildings. Tall buildings can sway and vibrate during an earthquake, which can make them more susceptible to damage. This is why architects and engineers who design buildings in Tokyo have to make sure that they are built to withstand earthquakes. This brings us to the type of insane engineering technique the main tower uses to withstand earthquakes that make it unique from other skyscrapers in Japan. The Toranomon Azabudai district main tower is a skyscraper currently under construction in Tokyo, Japan, and it's set to become one of the city's newest and most iconic landmarks upon its completion in 2023. The tower itself stands at a height of 330 meters, making it one of the tallest buildings in Tokyo. It will feature a mix of office space, residential apartments, and retail and commercial areas to transform the Toranomon Azabudai area into a hub for business, culture, and tourism. So, with a skyscraper this height, and Tokyo being on the fault line, that makes the city more prone to earthquake disasters. So does Tokyo plan to curb the damages caused by earthquakes while building tall skyscrapers like Main Tower in the future? We are going to be a bit technical here, so pay attention. But don't worry, we'll make it more interesting by simplifying it as much as possible. The Main Tower uses an insane engineering technique called seismic engineering to ensure its safety and stability during earthquakes. Seismic engineering is the branch of engineering concerned with the design, analysis, and construction of structures to withstand earthquake forces. Seismic engineering takes into account the seismic hazard of the area where the structure will be built, as well as the characteristics of the structure itself. Also, seismic engineering considers the structural response to ground acceleration. A building, for example, can move in several ways during an earthquake, such as bending, twisting, or shearing. The structural response depends on the size, shape, and material properties of the building, as well as the distribution of mass and stiffness. With all these put into consideration, the main tower in Tokyo uses these seismic engineering techniques to curb the damage from an earthquake. One of these techniques is seismic isolation. The building's foundation is designed to rest on specifically designed shock absorbers, known as base isolation bearings. These bearings act as a buffer, absorbing the energy generated by the seismic waves. In other words, earthquake vibration, thus reducing the building's response to the ground motion. The next seismic engineering technique main tower uses is structural bracing. The tower features a structural frame made of reinforced concrete and steel. The frame is braced with diagonal steel members that provide additional stiffness and strength to the structure. Another seismic engineering technique is the damping system. This is the most interesting and unique technique main tower uses. Now, another name for the damping system main tower uses is the split wall damping system. Let's dive deeper. The split wall damping system is a structural engineering technology used to reduce the damage caused by earthquakes to buildings and other structures. This system works by reducing the impact of the vibrations generated by an earthquake and dissipating the energy that can cause damage. The split wall damping system consists of two walls, an inner and outer wall. The two walls are separated by a gap that is filled with viscous fluid or other damping material. The gap between the walls allows the building to move slightly during an earthquake, which helps to dissipate the energy generated by the earthquake. When an earthquake occurs, the outer wall of the building will move back and forth, but the inner wall will remain relatively stable. The damping material in the gap between the walls absorbs the energy generated by the movement of the outer wall, which helps to prevent damage to the building. Other important techniques are soil improvement, since Tokyo is built on soft soil, and monitoring systems to measure the building's movements and vibrations during an earthquake, providing real-time data that can be used to optimize the building's seismic performance. This insane engineering technique is essential to reduce the loss of lives and properties during an earthquake and the cost of damage repairs. Now, with these fantastic features to curb the damage inflicted by earthquakes, is main tower not worth constructing to withstand earthquakes? Yes, it is. That's it, the insane engineering of the Toranomon Azubadai District main tower. With love and sympathy, we send our condolences to the lives lost in the Turkey-Syria earthquake and the families affected, with the hope that with this video, construction engineers can gather insights on how to fortify buildings against future earthquake disasters. We encourage you to make a donation to support the victims of this disaster. Tell us what you think about this building in the comments section below. Also, make sure you subscribe to this channel for more intriguing content.